students, and welcome to your first lesson in Unit 2, which is going to be on multiplication and division. We're going to start this first lesson on multiplying, specifically how you multiply whole numbers. Now, most people are familiar with what multiplication is, but this idea of whole numbers is something not as many people are familiar with. When we say whole numbers, we're talking about positive numbers, specifically those positive numbers you count by. So like 1, 2, 3, 4, 5. So this lesson is going to focus only on positive numbers like 1, 2, 3, 4, 5 and up. Don't worry, we'll get into how you multiply negative numbers, decimals, fractions, all those fun numbers in later lessons. But for today, we're talking specifically about multiplying whole numbers. In order to introduce this lesson, I've got my favorite, a picture of chocolate, and the question that we're going to answer, which is how many chocolates are in this package. Now before we answer that question, if I want to know how many chocolates are in this package, we actually have to make an assumption of something. Do you know what we're going to have to assume? Well, if I went to count all of these, there's something blocking my view. There's this sticker right here. We're gonna have to assume if there's chocolates behind that sticker or not. Now for this problem, we're going to assume there is. We're gonna assume that Ferrero Rocher is not ripping us off and that there actually are chocolates in these two rows here. So to answer the question, how many chocolates are in the package, there's actually a lot of different ways you can do this. So I'm gonna start recording some of the different ways you could answer this question, the different ways you could find the answer. Go ahead and try to describe all those different ways, not just the answer, but tell me what are some different ways you could calculate how many chocolates are in this box here. Well, the first one, if you're a little kid, probably the only way you know is to go and count 1, 2, 3, 4, 5, 6, 7, 8, and count every single chocolate in the package. So one way is simply by counting, right? You can count by ones. However, there are other things you could do to keep you from counting every single chocolate. One way you could do it is instead of counting by ones, you could go in and count by twos. You could say 2, 4, 6, 8, 10, 12. Count this whole thing by twos. You can also count by other numbers, specifically the entire column here. We could go and say 1, 2, 3, 4, 5, 6. And if I know this whole thing is 6, that would help me because the rest of this is just a bunch of different columns of 6. So I could say 6 plus, how many are there? There's 1, 2, 3, we're going to assume there's more here, 4, 5, 6, 7, 8. So that would give me 8 sixes. I've got 6 plus 6 plus 6 plus 6 plus 6 plus 6. I've lost track. 1, 2, 3, 4, 5, 6, 7, 8. So this is another way to do it, right? You could just add up all of those sixes. There are more ways. There are lots of more ways. You could also come in and say, well, instead of going this way, let's count horizontally. Let's count the rows. There's 1, 2, 3, 4, 5, 6, 7, 8 in one row. Well, how many rows do we have? We've got 1, 2, 3, 4, 5, 6. I've got 6 rows of 8. So I could also say 8 plus 8 plus 8, 4, 5, 6 of them. I've got 6 rows of 8. There are other ways you can do this too. Instead of saying 6 and 6 and all those 6s, you might already know that 6 plus 6 is 12. So we could count them by 12. So we could say 12 plus 12 plus 12 plus 12. So that would be 4 of them, 4 12s. And you could keep going with this. There are a lot of different ways you could figure this out. the question I've got is, what do you notice about all of these? What do they all have in common? Well, one thing students tell me they notice is they notice for each problem we're using the same number. And that's a good observation, right? Here I'm just using a bunch of 6s. Here I'm only using 8. Here I'm only using 12. So we notice it's the same number. The other observation students tell me a lot is they notice it's all addition. We're just adding the same number again and again and again. Now there's one last part. All of these were addition problems. There's one other thing you could do. Instead of using addition, you could say, remember this was 6 chocolates times 8. All of these problems are going to be the same thing as 6 times 8. What multiplication means is this. Multiplication, we say, is repeated addition, which just means you're repeatedly adding the same number again and again. So at any point in this class, in this lesson, in your life, you get a multiplication problem you don't know how to do, one option is always going back to this idea that it's repeated addition. There are lots of people who might know what like 2 times 3 is, but when you get up to those higher numbers, maybe like 9 times 7, if you don't immediately know what that is, it's okay. You can always just go back to this idea and break it down into an addition problem for yourself. So we could actually answer the question now. We've got so many different ways you can figure it out. How many chocolates are in that package? Well, I could do all this addition, I could count them by ones, but I know that 6 times 8 is 48. There are 48 chocolates in that box. I did say we had to assume that there's chocolates behind this sticker. If there are none, it's clever packaging, I guess, for them, but it would be less chocolates. But the reason I've chosen this picture, sticker and all, is because this is an example of something we call an array. When you're talking about multiplication, an easy way to visualize it is by using this idea of something in these rows and columns. So another example could be if I was talking about the multiplication problem 2 times 3. If you wanted to make an array, you wanted to make a picture like this, you don't have to draw chocolates. But you could just say, I want 2 rows of 3. Here's 1 row of 3, here's 2 rows of 3. And that would be another example of an array. I'm gonna go ahead and erase all of this. One of the key things we just said with this problem is the idea of what multiplication means. And so on this next slide, we've got multiplication is repeated addition. So I'll put one other example down for us. Another example could be something like the problem, let's do 4 times 3. You can make this multiplication problem repeated addition. I could either add 4 3 times, so 4 3 times, or you can add 3 4 times. It works both ways. So I could add 3 4 times. That's what we mean by repeated addition. Multiplication problems are just the same thing as adding one of those numbers many times. So now that we've talked through that, there are some practice ones for you to try. You erase all this. We've got the first one is about cookies. You can tell I was hungry when I wrote this. The directions say how many cookies are there in this array. Represent this picture with 2 different equations and answer how many total cookies there are. So notice there's 2 questions here. One question is represent it with 2 different equations, and then the second part is how many total cookies are there in this picture. Make sure you answer both. Okay. The other example over here, or other practice problem over here, is Samuel needs to add the following. We've got 3 plus 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 3. And the question is, what is another way to think of that problem? Okay. For this one, I wanted to talk through it a little bit because there's a lot of different answers you could put here. If you're just thinking of repeated addition in a different way, instead of saying 3 plus 3, we could say this is the same thing as 6 plus 6 plus 6 plus 6, or keep going with that and write more addition problems. You're thinking about changing it into a multiplication problem. We want to know how many of these we have. We've got 1, 2, 3, 4, 5, 6, 7, 8. So another way you could think of this is 3 times 8. You could have also written 8 times 3. One of the key things with multiplication is that the order you write those doesn't matter. They both equal out to the same thing. So this was our introduction of multiplication, specifically focusing on like what does it mean to multiply something. The next part of this is going to be talking about multiplication and something in math we call area. So the example we're looking at says Denise wants to put down new tiles in both of her bathrooms. The dimensions of her bathrooms are below. So this first part asks, if each tile is 1 foot by 1 foot, how many tiles would she need for each bathroom? So I've got these two beautiful bathroom pictures right here. And notice looking at this, you might be thinking, well, that looks similar to the picture from before, the array we were looking at, and you were right. This is another example of an array, Denise's bathroom. They're telling us that each one of these tiles in the bathroom is 1 foot by 1 foot. So this little tile here is 1 foot by 1 foot. And that makes the tile. The question is, how many tiles would she need for each bathroom? Notice over here they're giving you more information about this bathroom. Using this information here, go ahead and try answering the question. The large bathroom, which is this one, needs how many tiles? Well, how did you count it? And when we had looked at the first picture with the chocolates, we said one way you could do is like count all of these individually. But since the focus of this lesson is specifically on multiplication, notice they told me this side is 10 feet. That means there's 10 tiles here. This side is 6 feet. They told us which means there's 6 tiles there. We could find this out by just saying 10 times 6, which gives us 60. There are 60 tiles. What about that other bathroom? The small bathroom needs how many tiles? Well, same idea. We've got 5 times 5. If we multiply, that will give us, we need 25 tiles. Now in this problem, I never said the word, but what you are calculating here is something we call area. Area is all of this here. Area is the space inside a shape, or in this case, the space inside Denise's bathroom. When we were saying she needs 25 tiles, another thing we could say is the area of this bathroom. We could say the area is 25. We need a measurement though. Just like perimeter, when we were talking about perimeter of shapes, there always was that measurement at the end, like feet or meters. Same idea here. Area, we are going to say, is 25 feet, and then I read this right here as squared. Now if you only say 25 feet is a distance. I could say from like this side of my classroom to this side of my classroom, that's a distance, that's a length. I could say that is 25 feet. But when you're talking about space and not a single line, when you're talking about space, we say 25 feet squared. That squared, one way you can think of it is literally coming from how many of these squares are inside the shape. So when we say 25 feet squared, we're literally saying there are 25 squares, and each square is 1 foot by 1 foot, so 25 square feet. The area of this one's 25 square feet. What would the area of this one be? Same idea. We already found that there's 60 tiles in the bathroom. The area would then be 60 feet squared. It doesn't have to be feet. Maybe Denise measures her bathroom in meters, then it would be meters squared. She wanted to measure it in inches. I don't recommend that because inches are very small to measure a bathroom. But if she did, then it would be inches squared. Anytime you're talking about area, it has the squared part there. And you might have seen that in your real life before, right? If you've ever looked at an apartment or a house they tell you how big the apartment is, and they tell you it, at least here in America, with square feet, right? When I got my apartment, they told me the apartment is 700 square feet. Same idea as this. So to summarize all the stuff we've said, we've got area is the space inside a shape. Now I had mentioned perimeter, and once students see perimeter and area in a math class, it's easy for some students to start confusing them. So I'm just wanna real quick summarize the difference between the two. If you were talking about a shape, like this rectangle, the perimeter, we said, is the distance around the shape. So if I started here and I walked all the way around, let's say this is a bedroom. I started on one side and I walked all the way around. That is the perimeter. That is the distance around, I said it was a room, so the distance around the room. Area, get another color. Area is the space inside. I don't know if you're gonna be able to see that, so never mind. We'll switch back to black. Area is the space inside. So area is how big something is. And those two words I've been using are important. When we get into more and more word problems, if you see something that says we're going around the shape, that's telling you we're looking at the perimeter. If you're going around something, that's describing the perimeter. If you're talking about how big something is or how much space it takes up, those are both words that we would use when we're referring to area. You know, they could tell you the area of your apartment is 800 square feet, but they can also just say, you know, the size of your apartment is 800 square feet, or this apartment is 800 square feet, so it's larger than this other one. All of those words go back to this idea of area. Now there are formulas you can see for area. I do want to point out though, that you already saw how you find area. It's multiplication. All formulas do is tell you a specific way to calculate the area every time. When we're talking about a rectangle, the formula you see a lot for area is the area, so we use A for that, equals length, so we're going to use an L, times width. What that formula says is if you take the length of the rectangle and multiply it by the width of the rectangle, that'll give you the area. And that's exactly what we did in those earlier problems. For a square, even though the idea is the same, the formula looks a little different. For squares, we say instead of length and width, because squares have the same sides, we use the same letter. So I could just use S for side, and I'm using the same letter because those would be the same number. And then your formula would just be, if you multiply the two sides together, that will give you your area. There are more formulas for more shapes, more polygons in math, but these are the two we're going to focus in this lesson. So for practice, let me clear all this up. The first question says, what is the area of this rectangle here? All right, and then this other one here says Priscilla has a square garden in her backyard. Each side of the garden is 9 yards. What is the area of the garden? Okay. Hopefully you feel good about those two. I will say for this one, a strategy you could use for area, just like we did with perimeter, is if they're describing a shape, give yourself a picture. It can help when you go to actually do the math. The last part of this lesson is on how you multiply multi-digit numbers. So we said in this lesson we want to talk about multiplying whole numbers. All of the examples we've looked at so far have just been one digit, meaning I make up that number with a single number. So numbers like 1, 5, 8, those are all single digits. Multi-digit is going to be a number you make with more than one number. So for example, like 12, or 103, or 2,489. Those all I make with more than, I'm writing the number 12 using 2 numbers, I'm writing 103 using 3 numbers. We call all of these multi-digit numbers. So the last part of this is basically going to be focusing on how you multiply big numbers. The example we're going to look at is this one here that asks, what is the area of this rectangle? Now, we've looked at area questions a lot in this lesson. So, one way you can do is go in and count all of these. We also have learned that to find area, you multiply. So another way you could be thinking is multiplying these 2 numbers. They've already done the counting for us. So they're saying this side has 18 squares. This side here has 6 squares. So we could go ahead and multiply those 2. The way lots of people are familiar with multiplying these is 18 times 6. So stacking them on top of each other like that. And then starting here with the 6 and saying, well, 6 times 8 is 48. You write the 8 from 48 there, and then you carry the 4, similar to what we did with addition. And then after you multiply these 2, multiplying these 2 and saying 6 times 1 is 6, plus the 4 would give you 10, and then writing our 10 there. So we get 108. The visual to go with that, why that process works, is what you're really doing is you're saying 6 times 8. So in the picture, you're saying 6 times 8. 1, 2, 3, 4, 5, 6, 7, 8. So what you're doing when you say 6 times 8 is 48, is you're saying this spot right here, the 6 by the 8, has 48 of those squares. When you go to multiply the 6 times 1, you're not really multiplying 6 times 1 here. You're multiplying 6 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the 6 times the 10 gives you the 60, which is where the 60 plus that 40 gives you the 100 right there comes from. Again, if you know how to do this, this will get you the answer, but some people really like to know the whys behind things. So this is where it's coming from. What we're really doing when we say 18 times 6 is you're saying the 6 times 8 is the 48, and then 6 times 10 is 60, which gives you that 108. So just a visual to go with it. This example here was of a multi-digit number times a single-digit number. The last part is what you do when you've got a multi-digit number times a multi-digit number. So we'll start off, go ahead and try this one for me. It's similar to what we did in that last problem. Well, here you would say 8 times 2 gives you 16. You could say 4 times 2 is 8. Plus that 1 gives you 9. 2 times 1 gives you 2, so you get 296. The idea of multiplying this by hand starts the same way. The first thing you would do is the same thing you did over here. Ignore that 1 and just multiply the 2 with everything. So the 2 times 8 gives you 16. The 2 times 4 gives you 8, plus 1 is 9. And then the 2 times 1 gives you 2. The difference for this problem is we're not done. We still have 1 that we need to multiply. So we're going to do the same thing with that 1. We're going to multiply the 1 with each of these numbers. Now when I go to do that, the first thing I'm going to do is the 1 times 8, which gives you 8. Because we've moved over to the 1, when I go to start writing all of those answers, the first number is going to go right here. 1 times 8 gives you 8. I've moved under the 1. Some people leave it like that. Some people, it helps them to put a 0 here. That 0 is going to help you remember that you want to move over 1. So I could go 1 times 8 gives me 8. 1 times 4 gives me 4. And then 1 times 1 gives you 1. Now I'm looking at 2 numbers. Do you know what we're going to have to do to get our answer? Well, I'm going to add what I got when I multiplied the 2 to what I got when I multiplied the 1. And together that's going to get what we get when we multiply by 12. So I could say 6 plus 0 is 6. 9 plus 8 gives you 17. 1 plus 2 plus 4 gives you 7. And then we've got our 1 there. Generally, with larger numbers like this, you're gonna see a comma after the first, after the last 3. So 1, 2, 3, this is where our comma would go. It is not necessary for you to type those commas in your answer, but this is how you would probably see it written. So we get our final answer for that one. I do want to say, if it's been a while since you've multiplied these by hand and you're just kind of sitting there watching the video like, oh my god, what is going on? I am planning on posting some more videos on how you multiply by hand, just if it's been a while for you and you don't remember or aren't as familiar with what I'm talking about. But we do in class emphasize knowing how to do these things by hands. I know in the real world, if you're at the grocery store and you need to multiply something, we all have calculators on our phone, but there are still a lot of tests where the math section you don't get a calculator. For example, when you signed up for school and you went through orientation, they talked about the ASVAB test. I know that one you don't get a calculator. The AccuPlacer test to test into the Ivy Tech classes, you don't get a calculator. I've had some students talk about like their own certification tests they're planning on taking, they don't get a calculator. So, part of our school's philosophy is we want to make sure we're preparing you for whatever your future holds outside school, which is why we do spend some time in this class emphasizing how you do it by hand. So if you are struggling with that, we understand. Like I said, most of us just reach for that calculator on our phone now, so I get it. But we do want to make sure we give you opportunities to practice doing it by hand so that whatever that test is you're taking in your future, you'll be ready for it. So please reach out to us if you're having trouble with some of this multiplication by hand. I know it can be a lot sometimes. These are the last examples I had for you. There is one last one for you to try. The practice problem says, the pictures below show Erica and Becca's classrooms. Who has the bigger classroom? Explain how you know. So we've got Erica's classroom with the dimensions, Becca's classroom with the dimensions. Notice again, there's 2 parts to that question. The first part is who has the bigger classroom? Make sure you answer that. But also make sure you answer, explain how you know. Go ahead and try that one now. All right, that is all I have for you in this lesson. Tomorrow's lesson is going to be looking at division. Now that we've covered multiplication, that's what's coming up next. Hope you all have a great day. Thanks, bye.